AI agents and agentic AI are two completely different things. If you don't know the difference, you are already behind in the AI game. The rising global interest in this technology, as shown in this figure from Google Trends data, that highlights emerging of agentic AI is almost comparable to AI agents. By the end of this video, you will not only understand the difference between AI agent and agentic AI, but also you will be able to tell which one is more suitable to your use case. As we aim to clarify the difference between AI agents and agentic AI, we will do the comparison on these key dimensions: architecture, mechanism, scope or complexity, interaction, and autonomy. We will see sequentially how we progressed from AI agent foundation to agentic AI, followed by the architecture evolution, their core characteristics, role of foundational models, and finally we'll see some key differences on multiple aspects. AI agents are essentially autonomous pieces of software that build to achieve a specific goal inside the digital environment. What makes them powerful is they can take both structured data like spreadsheets or CSVs and unstructured data like text or image and reason about it. And they can take action to move towards their objective. Now here is the key difference from old school automation to the AI agents. Traditional scripts just follow a set of instructions where inputs comes in and output goes out. They always follow the same path. But AI agents, they are more flexible. They show what's called reactive intelligence. They can respond to changing situations, adapt when input shifts, and even reconfigure their output in real time. Their adaptability is what separates them from being just another automation script. There are four foundational characteristics of AI agents: autonomy, task specificity, reactivity, and adaptation. Autonomy is really what defines the features of AI agents. It allows them to function with little to no human guidance once they are set in the motion. After the deployment, they can perceive input from the environment, reason over the context, and then execute their predefined or adaptive actions in real time. To put simply, once you give them tasks, they can handle it on their own. For example, let me ask, find me the best restaurant for tomorrow night. An AI agent can search options online, check reviews, may even filter by your preference, and confirm the result with you. Coming to the reactivity and adaptation, this is where things really start to get interesting. Unlike static programs, AI agents are designed to interact with the real world, and that means they can handle dynamic inputs. Be it is a question from the user or external API providing fresh data or software environment changing state. It can search internet, use a calculator, access database, send emails, and even write code. Coming to the task-specific excellence, here AI agents are usually built for specific tasks. They are optimized to execute repeatable operation within a fixed domain, and each one is optimized for the particular job, just like specialist in any field. Let me give you some example you might already be using. Customer support bot that can actually solve your problems. Email assistant that prioritize and respond to messages. Now let's coming to the foundational models. They are the real brain behind AI agents. These are the engines that give agents their reasoning and perception power. Without them, AI agent would just be another static program. At the heart of the agent, first is large language models or LLMs like GPT-4, Sonnet, Mistral. They trained on massive amount of books, website, and conversation, and these models become the agent's decision-making core. They don't just answer questions. They can parse a request, plan out multi-step solutions, and generate human-like responses that actually make sense in context. But agents that are not limited to text only. They can also tap into large image models or large image models like Clip or Blip. These are trained on image text pairs, which means they can see and understand visuals alongside language. And this unlocks a huge possibilities, be it from robotics that can navigate space to autonomous vehicles that interpret the route. So if LLMs are the brains of language, large image models can consider as the eyes of the perception, and together giving an AI agent the ability to interact with the real world in a way that feels intelligent, not just pre-programmed. And combining large language models with large image models, it gives to generative AI. Here are the few key traits of generative AI. First is reactivity. Generative models only respond when you poke them. They are input driven machines. Give them a prompt and they will produce an output but on their own. They don't have memory or they don't have any internal goals or persistence. Multimodal capability. When you combine large language models with large image models, they can move across different domains, turning text into images, images into text, or even mixing the both. That's where you get things like text to image generator or captioning system. And the most important is statelessness. Each interaction is like a brand new conversation. They don't truly remember what happened before, unless you feed the context back in. Now, these language models act as the engine for the AI agent processes. Here is how it works. Let's break it into three layers. LLM has core reasoning components as the first layer. Think of large language models as the brain of the agent. They don't interpret user goals, they also map out possible actions, plans, and make strategies makes the most sense and manage multi-step workflows. On their own, they are very powerful, but paired with tools, they have become more capable. Next is tool-augmented AI agents that enhance its functionality. Here is where it gets more interesting. When an agent realizes it needs information beyond what it knows, for example, today's stock price, yesterday's weather, or maybe need to execute a script that doesn't just give up. Instead, it generates a structure function call or API request. It might look like JSON, SQL, or a Python dictionary. It's an orchestration layer that routes this request to the right service, gets the job done, and brings the results back. Coming to the third step of result integration. Finally, once the response comes back, the LLM don't just spit it out. It passes the results, adds to the context window, and then rethinks its strategy. It means it can update its progress, decide the next best step, and continue reasoning in real time. Frameworks like React are perfect example of this kind of architecture. In this figure, it illustrates an workflow of an AI agent, of a news query agent that performs real-time web search, summarize retrieved documents, and generate and articulate context-aware answer. Now, let's see the emergence of agentic AI from AI agent foundations. There is a conceptual leap from the isolated agents to coordinated agents when we are moving from AI agent to agentic AI. Right now, most AI agents integrate LLMs with tools and APIs to do very specific job. But here is a limitation. As soon as you need to context retention, interdependent tasks, or adaptability in changing environments, a single mod agent model just doesn't cut it. That's where agentic AI systems comes in. Think of them as an intelligent architecture built from multiple specialized agents, each handling a different piece of the puzzle and then collaborating through either a central orchestrator or decentralized communication. Let's see how an agentic AI in real time works in practice. First is goal decomposition. In goal decomposition, the system takes a big objective and automatically breaks down into simpler, smaller tasks. For example, imagine you give a goal like start a successful YouTube channel. First, a market research agent identifies trending topics. Then a content strategy agent builds a calendar. Then a search engine optimization agent optimizes titles and description. And then an analytics agent tracks the performance. And an improvement agent refines the strategies over and over. Each agent owns its task, but together they deliver a broader mission. Coming to the second step, multi-step reasoning and planning. These systems don't just run in a fixed order. They dynamically sequence steps, adjust when the environment changes, and recover if one subtask fails. Its flexibility baked into the architecture. Next, coming to the inter-agent communication, where agents talk to each other through distributed channels, like async message queues, shared memory, or passing intermediate results. It means they can coordinate without constantly relying on a central controller, making the system scalable and resilient. And the final is reflective reasoning and memory system. Here, agentic AI doesn't simply store context across sessions. They can reflect on the past decisions, improve their strategy over time, and this reflective memory is what makes them feel intelligent, not just reactive. If you see this image, it is an analogy of smart home system. In the left hand side, it represents a traditional AI agent in the form of a smart thermostat. It is a standalone agent which receives a user-defined temperature and autonomously controls the heating or cooling system to maintain the target temperature. While it demonstrates the limited autonomy, like learning user schedule or reducing energy uses, it operates in isolation, executing a singular and well-defined task. In contrast to the right hand side, it illustrates an agentic AI system that embedded in a smart home ecosystem. Here, multiple specialized agents interact with each other to manage multiple aspects like weather forecasting, daily scheduling, energy pricing optimization, security monitoring, and backup power activation. This figure embodies the architecture and functionally from task specific automation to adaptive and orchestrated intelligence. Next is the architecture evolution from AI agents to agentic AI. Before to that, first let's see what are the core components of an AI agents. Foundational AI agents are typically composed of four primary subsystems: perception, reasoning, action, and learning. Coming to the perception model, this subsystem intakes input signal from users like natural language prompts or external systems like APIs or file uploads or sensor streams, and it performs data preprocessing to create datasets in format interpretable by the agent's reasoning model. For example, in LangChain based agents, the perception layer handles prompt templating, contextual wrapping, and retrieval augmentation by document checking with embedding search. Second is the reasoning model. It is also sometimes called as knowledge representation and reasoning. This is their brain. It figures out the best way to complete a task, and it is the core of agents' intelligence. Reasoning in agents happen through function calling or prompt chain that simulates their thought process. For example, step-by-step prompt or intermediate tool invocations. Next is action module, where action selection and executions happen. It actually executes the plan using multiple tools that take actions, sometimes including sending messages, updating databases, querying APIs, or producing structured output. Here, we can use like LangChain's agent executor, which links LLM output to tools calls and observe the responses for the subsequent steps. Next, coming to the learning model. Here, traditional AI agents have limited learning mechanism, like simple memory buffer to recall prior user inputs or applying scoring mechanism to improve tool selection. Systems like React exemplify this architecture, where it combines reasoning and action in an iterative framework, where agents simulate internal dialogue before selecting the external actions. Now let's understand how an agentic AI is evolved from the AI agent system. Agentic AI architecture consists of first ensemble of specialized agents. Rather than operating as a monolithic unit, agentic AI system consists of multiple agents, where each agent assigns a specialized function or task, and these multiple agents interact via communication channels. Next is the advanced reasoning and planning. Agentic system embed interactive reasoning capability using frameworks like React, chain of thoughts prompting, and tree of thoughts. It helps agents to break down a complex task with multiple stages, evaluate intermediate results, and replan action dynamically. Next is the persistent memory architecture. Unlike traditional agents, agentic AI incorporates memory subsystem to preserve and persist knowledge across task cycle or agent sessions. It includes memory like task-specific history or long-term facts or structured data, and also sometimes it includes vector-based memory for RAG as well. And finally is the orchestration layers or meta agents. Orchestrators meta agents. This coordinates the lifecycle of subordinate agents, manage their dependencies, assign roles, and resolve their conflicts. Orchestrator often include task manager, evaluator, or moderators. In this figure, it illustrates the architecture evolution from traditional AI agent to modern agentic AI system. It begins with core model perception, reasoning, and actions, and it expands to advanced components like specialized agent, advanced reasoning and planning, persistent memory, and orchestration layer. This diagram further captures emergent properties like multi-agent collaboration, system coordination, shared context, and task decomposition, all enclosed within a dotted boundary, signifying layer modularity and the transition to distributed adaptive agentic AI intelligence. So first, we'll see the difference on basis of structural, functional, and operational difference. Let's begin with the foundation. AI agents are autonomous software programs that perform specific tasks like chatbots or workflow bots, while agentic AI is a system of multiple AI agents collaborating to achieve a complex goal. Coming to the autonomy, AI agents work independently within specific tasks, while agentic AI can manage multi-step with large-scale systems. In terms of complexity, AI agents handle single defined tasks, while agentic AI handle multi-step coordinate workflows. When it comes to collaboration, AI agents don't cooperate much, while agentic AI thrives on information sharing, cooperation, and teamwork. For learning and adaptation, AI agents adapt only within their domain, while agentic AI adapts across a broader range of environments. Next, coming to the conceptual and cognitive taxonomy, it indicates how they think. Let's look at the cognitive side. AI agent starts via user prompts or tools, while agentic AI starts with a goal and builds plan itself. AI agents comes with low flexibility, while agentic AI adopts goal dynamically. AI agents forget very quickly, but agentic AI remember across workflow stages. From the learning point of view, AI agents might do two strategies to learn, while agentic AI learn from its outcome. AI agents sometimes have optional memory, but agentic AI set episodic memory across tasks. Let's see the difference on their attributes. The primary capability of the AI agent is task execution, while agentic AI is autonomous goal setting. In the planning stage, AI agents are single-step planning, while agentic AI do multi-step. AI agents heavily rely on the rules or supervision, while agentic AI leverage reinforcement and meta-learning. AI agents are reactive, while agentic AI is proactive. An AI agent prioritize accuracy with latency, while agentic AI prioritize engagement and adaptability. Coming to the core function and goal, AI agent core function is executing specific tasks using external tools, while agentic AI automate complex workflows with orchestration. AI agents rely on an LLM plus tools, while agentic AI use multi-agent system with collaboration. From the architectural point of view, AI agents use single LLM essential prompts and APIs. They work with solo without any orchestration. Coming to the agentic AI that use multiple LLMs, system level goals, multiple tools, and explicit orchestration. This is why agentic AI can scale into complex workflows. Now, operationally, AI agents, their driver is tool execution. The workflow is single step with input flowing through tools to output, while agentic AI is driven by intelligent communications. They handle multi-step coordination where outputs from one agent is fed to another. That's collaboration in action. Coming to the task scope and complexity, AI agent handle single specific tasks like search with medium complexity, while agentic AI manage complex multifaceted workflows like converting YouTube videos into blogs. Complexity is high because due to of multi-agent coordinations. Finally, on terms of autonomy and interaction, AI agents have medium autonomy interacting via APIs or making tool calls which make tool user decisions. Agentic AI is of high autonomy, interacting across agents and tools, making decisions on goal decomposition and task assignment. Let me make some predictions based on what we have learned. Next 2 years, AI agent will become mainstream in the customer service, content creation, and personal assistant. In next half of decade, agentic AI will revolutionize complex industries like healthcare, education, and scientific research. And in the next decade, agentic AI system might be managing, optimizing traffic, power, water, and emergency services simultaneously. The bigger picture is we're not just talking about the better tools. We're talking about emergence of artificial teams that can tackle humanity's biggest challenges. Climate change, poverty, disease. These problems require coordination across multiple domains, exactly where agentic AI might excel are. So let's see some of the key takeaways. AI agents is one super capable specialist, while agentic AI is a team of specialists working together. While AI agents solve specific problems efficiently, agentic AI tackles complex multi-domain challenges. Both have roles, but agentic AI is the future for the complex problem solving, taking the help of AI agents. Now, here is what I want you to do. Start experimenting with AI agents in your daily work and look for opportunities where multiple agents might work better than one. If this video helped you to understand something new, you know what to do. Smash the like button, and if you want to more deep dives into a concept that actually matters, subscribe and hit the bell icon. In my next video, I will show what are the different use cases, challenges, and some recent advanced development in both AI agents and agentic AI. Till then, keep learning, keep coding, and keep growing.